Okay, so we're going to take what we talked about in the last video about balanced and unbalanced forces and free body diagrams and use it to think about falling objects. Okay, so before we do that, I just want to remind ourselves of the difference between mass and weight. And it's really important that you are able to use these two words correctly. All right, because you use these two words, I use them as well, incorrectly every day. All right, so if we talk about weight, so your weight, how much do you weigh, how much do I weigh, and we have a sort of a number in stones or a number in kilograms, that's not the weight, that is the mass. Okay, so mass is measured in kilograms, okay, and that is the amount of stuff, the amount of matter. All right, so if you have a kilogram of flour, that's not how much it weighs, that's its mass. All right, now your weight, that is measured in newtons, and that is the force, okay, due to gravity. So they are related to each other, so if your mass increases, then your force due to gravity will increase. All right, but very importantly, if I have, let's say you are on Earth, this is Earth, and this is the Moon. All right, now if you are on Earth, you will have a certain mass and a certain weight, and if you are on the Moon, you will also have a certain mass and a certain weight. But the important thing is that in both situations, the amount of matter, the amount of you that there is the same. All right, so between these two here, we have same mass, all right, because there is the same amount of matter in you. But you will have different weight. Why do you have different weight? Because gravity is different. Gravity on Earth larger than the gravity on the Moon. Okay, so it's really important that when we talk about these things in physics that we're using the right word. Okay, so we're going to be talking about the forces on objects as they fall, so we're talking about the weight of them. All right, so let's imagine that here you are, jump out of an aeroplane. Okay, now just after you jump out, okay, so let's say just after the jump, all right, we have this really big force due to gravity. Really big force due to gravity. Really big weight. And we have this little force due to air resistance or drag. So what does this mean? Okay, it means that just after you jump out of the aeroplane, your speed will increase. Speed downwards increases. Why? Because the forces are unbalanced. Now, let's say we wait a little bit, right? So a few minutes afterwards, maybe a minute afterwards, 1 minute after jump. What happens? Well, eventually we're going to get to a situation where the force due to gravity is equal to the air resistance. Okay, so remember, this is your weight, and this is the air resistance. Okay, now we have balanced forces. All right, so what does that mean? Does it mean that you stop and you are still stationary in midair? No, of course not. All right, you're still going downwards, so you're still moving downwards, but now, because the forces are balanced, it means your speed does not change. All right, so you're still moving down, so you're still falling, but speed does not change because forces are balanced. Okay? And then we're going to have the next situation is when you open your parachute. Okay, so why don't you have a go now actually, pause the video and see if you can draw yourself a diagram of what it looks like after you open your parachute and what that means. So hopefully you have a diagram that now looks like this. So you're going to have this really big air resistance force because the parachute is going to create lots of air resistance, and that's going to be much bigger than the force due to your weight. All right, it doesn't matter exactly how big these are, this isn't to scale, but the important thing now is that your air resistance is larger than your weight. So the question now is, what does this mean happens? All right, have a think. What does this mean? The force going upwards is bigger than the force going downwards. Okay, so at this point, normally, there's a few people thinking, well, if the force going up is bigger than the force going down, that means that I must move upwards. Okay? And you know you've seen that in videos of people doing parachutes where it looks like they open their parachute and they go up really quickly. Okay, that's not what happens. All right? It's not what happens. Okay? You do not move upwards when you open your parachute. All right? You are still falling. You are still falling. All right? But now, because the air resistance is bigger, the speed downwards decreases. The speed downwards is decreasing. Okay, the reason it looks like people move upwards when they open their parachute is because the person filming them hasn't opened their parachute. So they're still moving down really quickly, but the person that opens their parachute starts to slow down, so it looks like they move up. Okay, but they don't. You are still moving down, but you are decreasing in speed. Okay, and then finally we have after landing. And after landing, you have your weight and you have your reaction. And they are balanced, and you are now no longer moving, not moving. Balanced forces. Okay, so it's really important that you see here, forces are balanced and you are not moving. Whereas over here, forces are balanced and you are moving. All right, but the important thing is that in both cases, your speed is not changing. So here you are moving, but you don't get any faster or any slower. And here you aren't moving, and you also don't get any faster or slower. But If the downward force is larger than the upward force, then your speed downwards increases. If the upward force is bigger than the downwards force, then the speed downwards decreases. All right, so you might be thinking, well, what would it look like if you did start moving upwards? Okay, well, if you were in this situation here, and then for some reason the upwards force increased, then you would start moving upwards. That's unlikely to happen. Okay, good.